Picture the absolute ultimate stress test. It's the World Cup final, India versus Australia. We're in the 7th over, the bowler is steaming in, and right at this exact second, 50 million fans are aggressively hitting refresh on their phones for the exact same live update. They're on crowded trains, sneaking a look in office bathrooms, praying their flaky flight Wi-Fi holds up, and they expect to know what happened on the pitch within 2 to 3 seconds. Literally, that's the window. That is what we're talking about today.
50 million concurrent users. Honestly, that is a terrifying scale, especially when you look at the traffic curve. It doesn't gracefully ramp up over time. No, traffic spikes 100-fold in mere seconds when something big happens and then plummets right back down near zero. And through all that absolute chaos, your users demand to know exactly what just happened. If you're the engineer tasked with building this system, your very first instinct might actually lead you down a super dangerous path.
Because here's the stark financial reality of system design. A naive engineer is going to grab all those expensive, trendy buzzwords, massive NoSQL clusters, millions of open web sockets, and they'll rack up a mind-blowing $25 million monthly bill. Oh, and the system still falls over on match day. Meanwhile, a seasoned principal engineer, they use quote-unquote boring technology, and they solve the exact same problem for a fraction of the cost. We're talking around $250,000 to $300,000.
So, here is the principal engineer's playbook. First, we'll break down the 50 million user problem, then uncover some storage truths, reveal the ultimate CDN cost killer, rethink the entire write path, plan for epic failures, and finally, figure out exactly when you should and shouldn't use this pattern.
Part 1. The 50 million user problem. Realism over idealism.
The true problem statement really just comes down to the shape of the traffic. We're dealing with massive 100x spikes and this huge read fanout, but a remarkably low write rate. Think about it. A real-world update only happens maybe once a minute. Plus, there is brutal cost sensitivity and surprisingly a pretty high tolerance for about 1 to 5 seconds of data staleness. And listen, this pattern matters way beyond cricket. This exact traffic shape dictates how you need to build live election results, stock tickers, breaking news banners, you name it.
Part 2. Storage and access truths, and why boring tech absolutely wins.
Okay, the crucial thing to understand here is that keeping 30 million historical rows of commentary is, realistically, a pretty small, highly relational data problem. Now, engineers hear the word scale and instantly want to reach for Cassandra or DynamoDB, right? But this data is incredibly structured. Matches contain innings, innings contain balls. This means a well-tuned, boring old MySQL instance absolutely crushes NoSQL here. The data volume is entirely bounded and predictable.
Think of it like this. It's like a public library archive where every single book is filed on a precise, ordered shelf. You would never build a ridiculously complex, globally distributed library system just to store a modest, bounded collection of 30 million properly indexed books. One well-organized building does the job perfectly. Now, we have to talk about the WebSocket trap. Defaulting to WebSockets for anything labeled live is a massive, massive trap in this scenario. Doing that forces you to pay for 50 million persistent open TCP connections. But wait, remember our traffic shape? Updates only happen once a minute. So those incredibly expensive connections are literally just sitting idle 99% of the time. The alternative? Short polling. Simple, stateless HTTP requests firing every few seconds. Keeping a WebSocket open is basically like paying a private courier to stand at your front door all day, just waiting for a single parcel that might show up once an hour. It's so wasteful. Short polling, on the other hand, is just casually checking your mailbox when you happen to walk past. It is incredibly cheap, and here's the real kicker. It's embarrassingly cacheable.
Part 3. The CDN cost killer, or fan out via cache.
2. That is the actual number of requests per second our origin server sees per match during absolute peak load. Mind-blowing, right? You've got 50 million users polling every 5 seconds, which generates 10 million requests a second globally. But because we're using a CDN-first architecture, the content delivery network absorbs 99.99999% of that traffic right at the edge. The origin server is just sitting there, completely chilled out, sipping its coffee.
Because the absolute latest score is the exact same response for every single user on planet Earth, we use the CDN as a global printing press. It instantly makes 50 million identical copies at edge locations all over the world. Even if you use a blazing fast Redis cache, that's still just a print-on-demand kiosk. Sure, it's fast, but it forces every user to travel to one central location, creating a massive bottleneck. The printing press wins every time.
Okay, but what happens when that 5-second CDN cache actually expires? Normally, you'd get hit by a thundering herd where millions of users suddenly smash through to your origin server all at once. Total disaster. So to eliminate that, we use cache refreshing, also known as stale while revalidate. The CDN proactively fetches the new update in the background at about 90% of the time to live. Thanks to this brilliant trick, the users never, ever experience a cache miss.
Part 4. Rethinking the right path, and why cache before DB is exactly the right move here.
Now, any textbook is going to tell you to write to your database first, but using a hybrid routing strategy for our hot and cold paths changes everything. Instead of hitting the DB, we write to the Redis hot path first. Why? Well, the CDN cache holds data for 5 seconds. If you write to the database first, your users might end up staring at stale data for an agonizing 5 seconds while they wait for the next cache cycle. By hitting the hot view first, the CDN picks up the live update immediately. Bam! No devastating delay for the user. Meanwhile, the database gets updated concurrently as our durable archive on the cold path.
Also, keep in mind, commentators are usually working on terrible stadium Wi-Fi, so every single update uses idempotency. They upsert using a unique key, match, inning, and ball number. That means a retry storm from a dropped, spotty connection is never going to create duplicate entries or corrupt the database. It just applies cleanly every single time.
Part 5. Failures, spikes, and costs. Let's plan for the worst.
The real cost math here is absolutely wild. The naive design burns $25 million just keeping WebSockets open. By switching to stateless polling, those connection costs plummet to near zero. And by pushing bandwidth to the edge via the CDN, bandwidth costs drop from $5 million down to a measly $200,000. This proves that eliminating idle connections and utilizing edge fanout is exactly how you achieve a 100x cost reduction. You don't get these massive savings by writing slightly better code, you get them through fundamentally better system architecture.
And listen, to survive those 100x traffic spikes and the inevitable CDN or origin failures, this system relies on rigorous, production-grade observability. We're talking monitoring core SLOs using red metrics, rate, errors, and duration, alongside distributed traces to spot bottlenecks. We run active-active in multiple regions. We use backpressure to reject traffic cleanly rather than letting the servers just crash. And my absolute favorite, graceful degradation. If the origin goes completely offline, the CDN just keeps serving the last known cache value. Sure, users might see a score that's slightly stale, but the screen doesn't just go blank.
Part 6. Takeaways and when to pivot. The Principles Playbook. Now this approach is perfect for huge read fanouts where everyone wants the exact same identical data, like election results or sports scores. But conversely, if you need sub-50 millisecond multiplayer game state, strict financial consistency for a stop trading platform, or a highly personalized social feed, this design is completely wrong for you. It'll fall apart. You can't globally cache a uniquely personalized feed. Always let your specific data access pattern shape your architecture, not the other way around. So as you tackle your next big system design interview or major project, keep these 4 meta principles of principal engineer thinking in your back pocket. Number 1, match the system to the traffic shape. 2, remember that idle connections are pure cost. 3, use fanout via cache when millions want the identical read. And 4, always ask how does this fail before you even start building. Empathy, realism, and cost tracing are literally your most powerful engineering tools.
Which brings us to a final, slightly provocative thought to really challenge how you approach your next infrastructure problem. Ask yourself, are you building for the traffic shape you actually have, or the shiny buzzwords you secretly just want on your resume? Something to think about. Keep questioning the defaults, and we'll catch you on the next Explainer.